All right. I've been thinking about this situation most of the night. A lot of people think differently. I think at night. I have parts I've located, and I have tried to work through in my mind the circuits that are required. And I started making some sketches, which is sort of how I help think, where I start with a motor controller up here, and the motor controller runs the motor that runs the train, right? And I'm going to tap off of here for some motor sensors, whether it's going to forward or reverse or it's off. Okay, those are the three modes: forward, reverse, off. There's a power distribution board that feeds that motor controller. That power distribution board also feeds a buck boost board, or can feed a buck boost board. It also feeds a second buck boost board, which is for smart smoke. The buck boost, as you may know, takes track power, no matter what it is, from 5 to 15, and ramps it up or down to a level that we set. And in this case, I'm going to set this one at about 8 or 9, and I'm going to set this one here about 10. So smart smoke's going to get 8 or 9 volts, and that's going to run the smoke. And the not the fan, the smoke, the heater. This part comes down here, and it's going to have a puff and brake and idle. This is going to run the fan. It's going to run the fan with 10 volts or something like that, okay? Then that 10 volts is also going to trickle down and run the chuff soundboard. It runs real nice on 10 volts. Okay. Now then, the challenge was how to get signal without interfering and causing trouble with the motor control board. I am leaning on these guys working. I think these diodes work. So I'm going to try to put the diodes in a clump and pull off the power coming out, which is 5 to 15. I'm going to run it through a small chip. I'll get to that. I'm going to run it through a small chip that gives me 5 volts. I'll get to that. This now also needs to have the 10 volts goes out, goes through a 5 volt regulator, and then the LED that is turned on is going to signal to the puff and brake relay that sits up here, and it comes clear later. This all gets mashed together here in a second. You'll see. This is how I started my day. Then I thought, wait a minute. Let's simplify this. Let's just get down to the bare facts. We've got a motor, control board, and a motor. We're going to use diodes. I'm going to use, oh, my finger's in the way. I'm so sorry. We're going to use a 7805, which is a very simple chip. Well, they were here a minute ago. There they are. There you go. This is a 7808. This only gives me 8 volts, but I think that's all I have. I'm going to look, see if I have a 10. If I don't, this is what I'm going to have to use. So this guy is very simple. He takes a positive here and a negative here, and then this becomes your negative out. This is the positive in, negative out, positive out, so that you can give him, you can give him track power anywhere from 5 to 15 volts, and he will output 8 volts, period. So the challenge that I do have here is if he's below the 8, you're going to get below 8. You're going to get something like 5 to 8. That's the range you're going to get. So you have to make sure the 5 is going to work. What this is going to do, this is simply going to turn on an LED. Very simple. And I've been studying on how to power and run LEDs to get the maximum light. You have to put a resistor in circuit to keep the milliamps controlled, or you'll burn this out prematurely. The milliamp limit that they talk to is 0.04 amps. That's called a milliamp. And what we're looking at is 0.02 maybe 0.03, but if we stay below the 0.04, this diode will last a long time. The challenge I have is I have to check the transformer at 5 to 15 AC. It goes through DC. Now it's out to DC, and it's 5 to 15. Now I got to check what's the amps that's going to go through that bulb when in that condition. I measure it, and then I determine what resistance do I need. It could, right now I have a 1K, which is probably getting this down to a 0.001 milliamp, very low light. So I'm going to raise it. It's going to be somewhere between probably 500 and 100. I don't know what, but it's going to be a much brighter LED. The other thing is, brighter LED gives me a better chance of the light sensor working properly. Now, I'm going to power the light sensor with its own source. Now I have another one of these chips, and it's a 7805. And guess what? It takes whatever this buck boost is tuned for. Of course, it's going to be tuned for 10 volts because it's feeding all those other things 10 volts. But here, I'm going to put this chip in here, and it's going to bring this down to 5 volts. And the 5 volts goes to the relay, and the relay is rated at 5 volts. It likes 5 volts. So if I have a nice bright light here, I should get a very strong continuity when light is on, and most of this 5 volts will go through here. It'll fire at 3 or 5, 3 to 5. So a single LED, single light sensor, a pair of chips instead of these bulky regulators, but I still need the buck boost that I have for the other guy. So I'm going to have to put the buck boost back in, but all of the other support stuff can be small, and I'm hoping all of this and all of this will be in the tender, so that what goes back to the engine is the relay, the 10 volts for power here, and so this would be the 5 volt on off, 10 volts to run it. I'm not sure, that might be it. And then, okay, so I thought through the detail. This is what I'm going to build here in 2 seconds. Then I started looking at, okay, let's look at the big picture, make sure you don't miss out on anything. So I've got it here. I've got these pieces all figured out. I'm looking at the big pieces, and I was trying to make sure, do I know what, where, and where? And I went through it one more time to kind of organize it. And so I now see what goes to the engine is the buck boost to the smart smoke, 2 wires to the engine. The relay trigger comes back to the engine, and the 10 volts to run the puff and brake comes from the engine. So I'm going to have 6 wires coming from the tender to the engine to make this work. And that includes smoke. Oh, well, okay, if I include the motor, all right, then I got 8 pairs of wires coming in. It's a lot. We've run, the original engines ran 2. Later they went to 4. Later they went to 5. They shared a ground. Most of the conventional engines will go 6. So I'm going to go 8. I'm going to have to go 8. That's just the way it is. But that's going to relieve the bulk in the engine and keep some of the bulk down in the tender where we have a little more space. So this is the game plan. A single LED at maximum power and a single receiver getting 5 volts down here. Where do I put 5 volts up there? I think that might be right. I think that's what I said. I'm going to use a pair of 5s. And I know why, because I have them. How's that? So I'm going to put 5 volts to the LED, and I'm going to tune it with that resistor. So I got max power, max looms. Okay? And I got to worry about that below, say 30 milliamp is the target for that. Okay, so that's test. Set that up and test it and get it working. Then bring this guy in, bright light, get him the 5 volts, and see if he can trigger the relay. So I got to run that test and this test, and then I can say, this is how it's going to work, and it won't affect the motor, it won't affect the motor controller, and it'll be reliable. That's the game plan. And then I'll build test boards, but then once I've got it figured out, I can build a PC board like I did for the Puff and Chuff, and then that will organize those parts a little more, and hopefully I will find a spot in the tender somewhere, somehow. That's a game plan. So I'm going to kind of take this apart. I'm going to find some other things that I've already built that I can reuse that have the diodes and some of the other pieces that I'm going to need, and we'll just see what I can come up with. And I only have 1 hour. Oh boy, later.